All right, gents, for this video, have your lesson 5-4 worksheet open. I'm going to go over some of the notes about probability. So today we want to be able to write an equation or expression or fraction or ratio in order to describe the probability of an event and possibly be able to solve for that probability. So I'm going to go through the notes portion and a couple examples, and then you will go ahead and complete the 2 practice problems that are on the worksheet on your own and submit those on Google Classroom. So we're talking about probability, and the probability is the chance that something happens. And when we talk about probability, we're going to talk about 2 things, 2 terms that we want to know about. Or 2 types of probability. And the first 2 terms that we kind of want to know about are outcomes and events. And so outcomes tell us the total number of things that could happen. So I'm going to write what could happen versus the event is what actually happens or what I want to happen. So if I was talking about rolling a die, a 6-sided die, an even fair 6-sided die, the total number of outcomes would be 6. And if I said, okay, well, what if I want to roll a 1, or to win, I roll a 1, then my event would be 1, not necessarily just because I'm rolling a 1, but because I have 1 chance of being correct. So we can roll a 1, and that's going to be one event. Or I could say roll an even number. And because I have a 2, a 4, and a 6 on my die, that gives me 3 chances. And so that's 3 different events that could make it correct. And so we express probability by the events over outcomes. So probability is a fraction or ratio that's equal to event over outcome. So our number of events over number of outcomes. So if we're talking about rolling a 1 on a die, we have 1 chance of that being correct. And so that would be 1 out of 6 possible options. Or if I'm talking about rolling even numbers, I have 3 chances to be correct out of 6 possible options. And we call this theoretical probability. Because I'm not actually rolling my die to see what happens. Because if I just roll it 1 time, I could get a 2, 3, 4, 5, 6, and I could be wrong, right? But theoretically, if I roll the die enough times, let's say 10 times or 100 times or 1,000 times, 1 out of every 6 times, I should probably have the number 1. Or 3 out of every 6 times, I should roll an even number. And so we call that the theoretical probability. And so if you want to take a look attached to your lesson worksheet, I provided 3 websites that have random generators. So if you click on it, it'll roll a die for you and tell you what you get. And if you're having trouble kind of wrapping your head around this, go try it. Go roll the die 10 times or 20 times and see what happens. Record what you get. And the more times you roll it, the closer you should be getting to this 1 over 6 number. If you have a die at home, you can do it that way, or same thing with flipping a coin. So if we talk about the theoretical probability of flipping a coin, 2 things could happen. If I have a normal coin, I could get a heads, or I could get tails, right? And so this is 2 possible outcomes, so 2 outcomes. But if I said, what's the probability that I get a heads? Well, out of 2 outcomes, that's 1 event that I want to be correct. So that would be 1 over 2. So that's theoretical probability. Experimental probability, on the other hand, is based on its name, based on an experiment, or based on something that I've counted. So in our example here, Sam took 30 free throws and he made 20 of them. So 20 actually went in. Okay, so we're going to still use these same terms, outcomes and events, but here my outcomes are a little bit different. It's kind of the total number of chances that I had, 30, because I threw it 30 times, versus the events that it actually went in. So this is going to be kind of my event measurement. And I could do the opposite also. I could say how many times did it not go in, and that could be a different event, and I could consider it that way also. And whereas with theoretical probability, you know, there's a hard number in terms of the ratio or the fraction that goes between two. You always know there's going to be a 1/2 chance on heads and tails, right? But something like free throws depends on how good you are. If I'm throwing free throws, it's probably not a very high probability that it's going in, versus one of you is probably going to have a much higher probability of it going in, right? And so if we're going to write this as a probability, I'm going to have 20 as my events over 30 outcomes. And I can simplify that. I can divide by 10, numerator and denominator, and get 2 over 3. Well, now we could compare this. So Sam, it says, gets 2 out of every 3 shots. That's pretty good, right? So now we want to compare that 2 over 3 that he usually gets, his usual accuracy, to, you know, the next game or the next season. So some later time, he takes 45 shots. So now 45 is our total outcomes. How many would we expect him to get right? Well, we would expect him to get 2 out of every 3 of those correct. And so kind of in the same way, we're trying to figure out what's an equivalent fraction that would be out of 45. And that would tell me how many he got correct. Now we can do this in a couple ways. So I'm going to put x over 45. I'm going to flip to the next page and show you 2 different ways that we could think about this. So we could say 2 over 3 is equal to x over 45. And in our worksheet, it shows us using cross products or cross multiplying. So this is something you've probably seen before. And basically we're doing kind of our inverse operations like we do with fractions. And so all we're saying is that I want to get rid of these denominators. So I'm going to multiply times 45 over 1 here and 45 over 1 here to get rid of this 45. Well, if I want to get rid of this 3, I'll multiply times 3 over 1 and 3 over 1 and get rid of this 3 and this 3. So on this side, I'm left with just 45 and 2, which makes 90. And on this side, I'm left with x and 3, which just makes 3x. And so if I solve, I divide by 3, and I get x is equal to 30. So 2 over 3 is equal to 30 over 45. So the next time that he goes and he takes 45 shots, so I would expect him to get about 30 of them. Another way that we can think about doing this, so we have 2 over 3 equals x over 45. And you might have seen this before, it written more like this, where we kind of circle. And the only reason I wanted to walk you through the process before is so you kind of understand where that came from. So if we circle like this, I just don't want you to lose track of what we're actually talking about. So when we do this, we're multiplying 3 times x. And we're putting that on one side of the equal sign. I'm going to bring my equal sign down. And then 2 times 45, and I get 90. And you could do that the other way, because this is the same as 90 equals 3x, right? And that's what I had up here. So again, I divide by 3 on both sides. And I get 30 is equal to x. And so again, I would expect him to get 30 out of 45 shots. I'm going to show you one other way that you could think about this. We have 2 over 3 equals x over 45. And this is going to help you once we get to doing rates and ratios in the coming days. One way to think about this is like our equivalent fractions. So to get from 3 to 45, what do I have to multiply by? Well, 3 times 15 would make 45. If I do that in the denominator, let's do it in the numerator. Times 15. So 2 times 15 would make x equal to 30. 2 times 15 equals 30. So again, I'm getting that x is equal to 30, and it's just another way to think about it, another way to write it. So go ahead and do those 2 practice problems if you have trouble with them. Again, please take some notes down. Please try to send me a message or hop on one of our Google Hangouts so that way we can talk about how to do these. And hope everything's going well with you. Goodbye.